Okay, welcome back. We are going to take what we did yesterday, which is our collision detection. We got collision detection working. So now we're going to actually apply the logic for this collision detection. So I'm hoping we'll be able to get some functionality working by the end of this episode. And hopefully that music isn't too loud for you guys. Some Sonic Pi music while I'm programming. Okay. So this is the whole block where we do it. We need to do this differently because we were doing the overall collision here, and then we were doing a use case of like if we're the same Y, and then we would have had an else if enemies higher or else if ostrich higher. But we're doing this differently, so maybe we just keep this as a sort of template, and then I'll just build my real code above it. So we're saying for the index platform, no, not platform, the index vulture in the table of all the vultures. This is Lua's way of saying, it's Lua's way of saying iterating over a table. So this will do something a vulture's amount of time. And right now there's just one vulture, but when we turn on the other one again, it'll do it for both. And then ultimately when we have 5, it'll do it for all 5 or whatever it is. So the thing is with this, we need to detect either a top or bottom collision first, because that needs precedence over the left and right. And I guess we need that precedence because we don't want to accidentally trigger a top collision when it is a side collision. And since the top collision's logic, no, actually, we might be able to get away with that. Anyway, I think I'm gonna do a if top collision just to make it more readable, or like a, we'll say if self top collides, and that's top collides means the bottom of our vulture gets hit. So we need to do something to our vulture. Well, so we'll say if there's a top collision on our vulture, no, top collision on us, then do something else if bottom collides. Do I not have that? There we go. And then do something else. And then, left and right. I love that we just got right into writing code this episode, because the other ones have been like theorizing and everything, but we did all the hard work yesterday. So we've got, if we top collide, do something, else if we bottom collide, do something, then check left and right collision. And then it's almost like, so the other things that we need to keep track of are what logic needs to change depending on which direction they're facing. And this is where it's going to get a little redundant, because they're both facing right, both facing left, one facing left, one facing right, and then swapped. So there's 4 different conditions we need to check for every one of these, if the logic is different for depending on where they face. So we kind of have to work that out as we go But let's see. If our ostrich top collides with a vulture, we die. So we know we die. Doesn't matter which way we face, we die. Doesn't matter which way the vulture face, we die. Because the vulture's joust is higher and it's colliding with us. So we don't need the facing right in this instance. We just need to say self.exploded gets true. And that'll trigger the explosion sprite. And then after the explosion sprite's done, that'll trigger self-death. Or self, what is it? Yeah, self-death to be true. Self-death gets true. Okay. And was that the only thing that we need to happen? No, we need to bounce our vulture. So we need to take, and we need to reset our vulture's position. So we need to say that not ourself, but our current vulture's dy actually gets reversed. And there is gravity, so it'll bounce. It'll bounce still and then continue to fall because as long as we're in the air, you get a gravity applied as long as you're not grounded. So we're gonna say dy gets itself times a -1 to flip it, and then we're gonna set our y to be not colliding anymore because there's still technically there's still technically a hitbox on our ostrich when we're exploded, but we're actually not updating any of that logic. Actually, maybe not. No, yeah, we are. Right here, if we're not exploded, then do all this stuff. So if we are exploded, it won't do any of this. So we don't have to worry about that. We just need to set our vulture's y to be the ostrich's last y offset by our vulture's height. So upon a top collision, no matter what way we're facing or the vulture's facing, we would die. Yes, because the vulture's above us and they collide with us. Then we make the vulture bounce. And it'll bounce a little bit less than how fast it was going. It'll be a little bit less because as it's going up, it's still getting gravity applied to it. So gravity will keep getting applied until it's 0 and then. But here, let's figure out. My plan is to just try to do all the logic for it, then turn off our mouse stuff, spawn 2 ostriches, and then kind of test and see what works and what doesn't work. So if we bottom collide with an ostrich, that means, or we bottom collide with a vulture, that's the same logic where we say, no matter what direction we're facing, our vulture gets exploded. But the thing is, vulture doesn't need exploded. Vulture needs like eggified. Yeah, because vulture. So we have to. I think the way we're gonna do this, instead of adding our egg to our vulture class, I think I'm gonna make a new egg class, and our vulture will get an instantiation of it if it's exploded. So I think exploded is fine. Exploded just means we're gone. Like, yeah, we're exploded. So vulture gets exploded. We need to bounce us. So our self dy needs to get its current dy times the -1. Then we need to set our y position guess we don't really need to do that. We don't really need to do that, but I guess it's good practice. We want to set it to the top of our vulture, but higher by a self.height. So it's right at the top of that. And it doesn't matter which way they are for those top and bottom collisions. If it's a top or bottom collision, some death is happening. So I think that's right. So let's build this out. So if we left collide, then we need to check, hey, are we facing right? If self.facing right and vulture.facing right, do something. Else if, no, we don't want an else if, we just want another if. No, I guess it doesn't hurt to do an else if. Yeah, it doesn't hurt. Else if self.facing right, or we'll do these two first. We'll do the same direction first. So we'll say else if not facing right and not vulture.facing right. Then do something else. Else if we're facing right and vulture is not. Do something else. Else if not self-facing right and vulture dot facing right. Okay. 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 So those are the 4 different things. So what needs to happen if we, here we go. Here's our ostrich. If we left collide with an enemy and we're both facing right, that means in ostrich, that means a vulture hits us in the butt and kills us. So we would be exploded. And then that's it, because the vulture will just run right through it. I don't think it'll even bounce around. It'll just run right through us with a joust. We can test the original for that. Okay. Here we go. What if we were both facing this way? That means we would hit the vulture in a butt. So we would just set our vulture dot exploded gets true. And we'd have to test if the vulture bounces, but we've got that line in there to remind us. Else if we're facing right, if we're facing right and vulture is not, this collision probably will never happen. No, it could happen. I think we should bounce. So if it's a left collision and we're facing opposite directions, that means our butts are touching. And if our butts are touching, I don't think anyone should die if butts are touching. That's kind of my whole platform. So we should probably just swap our dx values. No. We would only swap our dx value. Because it's like, if my butt hits a vulture's butt, we don't want the vulture to turn around to swap its dx. We want to bounce off. So we'll swap our ostrich dx, we'll reset our x position, and we won't really touch the vulture. So we'll say our self dx gets swapped. Yeah. And we're actually, yeah. We should move us. We should move us in this scenario. So our self.x gets the vulture's x plus its width to be the right side of it. Do we need anything else? No one dies. We just swap our velocity and move us out of colliding for the next frame. Then our last condition, if, oh well, this is our last condition for our left collides. We still need right collides. Okay, here we go. Not facing right. So our ostrich is facing left and our vulture is facing right. And there's a left collision. This is where it's a little tricky because this means our jousts are touching. So if our jousts are equal, meaning our y's are the same, we need to bounce both of us. We need to swap our dx. But if ostrich is higher, vulture dies. Vulture higher, ostrich dies. So we need to say if self.y is equal to, not assignment, equal to our vulture's y, else if our y is higher than our vulture's, and then else, but we can be verbose about it just to kind of help us see what's happening. So okay, so if we're equal, we need to swap our dx. Our dx gets our current dx times a -1. We need to swap our vulture's dx to be the same, because this is like our joust tips are touching, so we're gonna just swap our dx. We move the other direction, but we also need to move our x. Maybe I'll do that up here. Self.x will get, no. We don't need to move two characters. We only need to move one character, and the character we should move is the vulture just because we're the main player. So we're just going to move the vulture so it's not colliding. We could, upon a collision detection of a side like that, decide that, hey, however much they're overlapped by, find the middle part of that and then move both of them so that they're aligned, which would look more right. But I think the collisions are so fast and we're not moving fast enough for it to really make a difference. We'll see. But I'm just going to move our x to be the left side of our ostrich. So it would be self.x minus a vulture's width. And that would make it so that we're not colliding. It doesn't move our ostrich, but it moves the vulture. I think that's okay. Then if our y is higher, that means the vulture's lower. So like vulture has higher lance, and because it's indexed at love 2D is indexed 0, 0 at the top left. So when y is increasing, we're going down. When y is decreasing, it's going up on the screen. So when self y is greater than the vulture's y, that means we're beneath it. So that means the vulture has the higher lance. But if our self y is smaller, that means we're above it actually. So ostrich has higher lance. Okay. So if vulture has higher lance, we need to do a couple things, or just one thing. We need to explode, right? Yeah, we wouldn't, Yeah, I don't think the vultures bounce if they kill you with a side collision. I don't think they bounce and swap their DX. But we'll see. So I'm trying to get killed by an ostrich and see what happens. If the I'm trying to get a side collision and see. Come on, guys, really? Look at these sons of bitches. They're just only up there. Great, great. Okay. So I need a side collision. Oh my god, really? Kill me? No. Okay. I need them to be flying. I need our Ys to be different. Yep. And then, oh, yep. Okay, yeah. They don't swap. They don't swap their DX like I thought. Okay, yeah. Cool. So, yeah, we just keep them flying. We just get exploded. So, yeah, self-exploded gets true. If we have higher lance, then vulture gets exploded. And we need to add in the egg here. We need to add a class and then add rendering and new egg logic for bouncing and whatnot, but that'll be not today. If ostrich has higher lance, then vulture gets exploded. And we would also do, once we figure out the points and everything, we have to do something for this. Once vulture's exploded, give us points or whatever. But this looks like the last of, that looks like the last of our code here. But if we look at this, enemy left collides. So I'm going to copy all of this real quick. Just because we need to make sure we're covering all these same use cases. If enemy right collides, yeah, we need to do, I'm gonna just delete the code so I don't get confused or we don't keep wrong code by accident. And we'll just talk through it and make it. Okay, so here's the boilerplate. Let's figure this out. So this is a right collides now. So if our ostrich is this and our vulture is this, then if we're both facing right, that means we hit the vulture in the butt. So the only thing that needs to happen is vulture gets exploded. Okay. If we're facing left and vulture's facing left, that means vulture hits us in the butt. That means we need to explode. If we're facing right, vulture's facing left. If we're facing right, vulture's facing left. That is going to be our collision lance height logic, and it's different there because they're on different sides. So with the right collision, we need us to be facing right and them to be facing left, whereas on the left collision, right here, this left collision, we have it so that our lance logic here is only if we're not facing right and they're facing right. So it's just a little swapped, but same principle. We're gonna swap our DX. We're gonna swap our vulture's DX. We're gonna reset just the vulture's X. We're going to reset it to the right side of the ostrich. So we're going to say vulture's X gets ostrich X, no, self.x plus the self.width. So the right side of our ostrich. And then vulture has higher lance. That would be a self-explode. And if we have the higher lance, vulture exploded gets true. And then our last one, which is we're facing left, they're facing right. That means our butts are touching. If our butts are touching, so a difference between us and the vulture is when we're in the air, we can actually turn. We can be facing right but have a negative dx, and we can be facing left and have a positive dx, where the vulture is going to be just facing whichever direction its dx is. So if our butts are touching, since the vultures can't move left, if there's a right collision and we're facing opposite directions, that would mean we would have to be flying towards them, and we'd have to be facing the other direction for our butts to hit. And if that's the case, I mean, it's the same shit. We just need to swap our dx, and then we need to reset us, not the vulture, because we don't want to mess with the vulture, since he, just because we touch your butt with our butt shouldn't mean you have to change any of your position. We'll give the vulture that. So we're going to reset our x to be the vulture's x minus a self.width, to be an ostrich width away from the leftmost side of our vulture. And I think that's all we got to do. No, we got to... Yep, we're good here. Okay. Okay. So here's all the code we did today, right here. And now I'm thinking I'm just gonna do I'm gonna do a small git commit right now, just in case I screw anything up here. I just want to have a snapshot. So I'm gonna say added collision logic, but still have mouse vulture. Okay. Then we can worry about turning off our vulture logic to be assigned the mouse stuff. So we're saying forget your mouse logic, and instead of drawing us, no, okay, cool. I'm glad we didn't put draw at mouse x and mouse y. We were able to leave all of these selves like that because we were assigning it right here. So those 2 lines of code saved us 8 changes here. Actually 10 changes for these 2. But we turned off the mouse. So now I'm going to see if the vulture's just spawning correctly. God dang it. 235 in our ostrich. What are we missing, dude? Function arguments near then. Function arguments near 235. That's because this needs a vulture to compare it to. I can't just run the function takes a parameter. So we'll just make sure all our collides functions are given the parameter vulture, which is the vulture object in every index of this table vultures. So it'll help us scale that when we make more. Where's the last here? Okay, so we have right collides, left collides, bottom and top, all with the correct parameters. So hopefully it won't yell at us. Okay, cool. So let's see. Let's see if we bounce. Actually, we should stay stationary. It should bounce. Yeah. And then if he hits our butt, we explode. Nice. So let's see if it swaps our dx. Yeah, it does. When our dx is 0, 0 gets swapped times -1, so it doesn't really do anything. So this is working. Now we'll see if we can kill him by having a higher joust. We didn't. We didn't. Okay. So us facing right, them facing left is not triggering their death. Oh, but the bounce worked. You saw that. So can they, yeah, they can kill us if we fly into them. Dude, yeah, I hit him with my butt and do you see me bounce? Oh, dude, that was sick. That was sick. I just gave myself a new life. My lives are 0, bitch. I'm still playing. I made this game. Oh, that's something I didn't think about. Did you see that? I was able to like sit on his head because we were detecting a top collision, so we were resetting our dx. We should actually give our dx a because if our dy is small enough upon bouncing off the top of a vulture's head, we can detect multiple collisions. Because our dy was so little. Yeah, did you see that? That's actually kind of cool. So if we give ourselves the same speed as him, close. Fuck. Shit. It's hard to get the same speed. Okay, here we go. So as he comes up on us, I'm going to try to land on his head and see how long we can keep the top collision going. Okay, so we're not spawning vulture death correctly. I just want to check. We are assigning, oh, well, our vulture, no, we do insert it here. Okay, well, let's turn off our mouse vulture. We'll turn off the insert for our mouse vulture and we'll put it together so we can see. Bro, that is not the first time I've done that. Command cut and then command copy instead of paste, and it just overwrites the clipboard. Okay, let us get both of these original vultures back. Okay, and let's see if X, Y with height platform spawn. But it needs a Y. Okay. So look, we can't kill them just yet, but they can kill us. But if our joust is higher, we should be able to kill him, but it doesn't. So what's going on there? So if we were facing right, and it was a right collision, and they were facing left. So if we were facing, here, let's go see it. If we were facing right, here's our enemy collisions. It's right here. Okay, so it's a right collision because we were on the left, and we were facing right, and vulture's facing left. Then yeah, we were saying if our y is here. So if our y is smaller than, if our y is greater than vulture y, that means vulture has higher lands. So this vulture, else if self-dot y is smaller. Let me see. I want to swap these and actually say we're going to see if we get exploded first. Or we see if the vulture's exploded before we see if we're exploded, and see if that changes any of the behavior. And if it does, I might do something different. So I'm going to see if I can kill him by having a higher y or a smaller y, but it doesn't. What's going on here? It resets us to be the right side. What's going on? This line of code's never executing. We're facing right. They're facing left. Okay. This should work. Our self.y is smaller, meaning we're above them. Vulture's exploded. Okay. God damn it. I don't know why it's not. Because what is happening? It's moving us. It's moving us to the right side, almost as if we did a facing opposite directions collision. So maybe I did fuck this up with the here. If not facing right, meaning we're facing left, and vulture's facing right, that should be the butt collision. No, yeah, we should have it right because we're facing right and the vulture's facing left. So I'm just gonna say if we get this right collision and we're facing the direction we are, just explode the vulture. And if it doesn't explode here, then something deeper is wrong. If our y is higher, oh, actually it shouldn't matter. Hold on. I need to comment out all this other stuff. Okay. We should, yeah, if, oh God. I'm looking for the vulture to just explode and disappear. It doesn't. So something deeper is wrong. I'm gonna see. I want to see if this right collides vulture is getting populated. Actually, hold on. Because we're drawing the collision. Okay, this is a little different. I'm going to copy all this. And I'm going to turn this off. Because we don't want this debugging to be tied to the vulture render, because then we can't differentiate between our different vultures. But if we move it out to our play state, we should be able to fill this with saying a proper vulture. So like, I'm just gonna turn off one of our vultures. I'm gonna turn off the top one because I think turn off this one. And then this is just the vultures one. So we just need, no, we can't do this. It likes it stored. It doesn't like the index. It likes an actual object. So we just have to say this vulture one gets the instantiation, and then we insert the instantiation into the table. Yeah. We're gonna have to, I probably should have just copied the code. Here, I wonder if I can copy this code and then undo it to where it was before. There we go. Because this is the way we want it. But this is the way we want it when we're debugging it. And that worked. So we can, now we have an instantiation of our vulture. We insert that instantiation into the vulture's table, and now we should be able to print out in our play state whether or not it collided with a vulture one. So, because when we had this debugging in the vulture class, each vulture got these values changed, and what we were printing was the current vulture's setting, so whichever vulture was second. So it was overriding all the vultures once, so it would make it impossible to debug just the first vulture. So now we've got it set up like that. So now we can see all of these false, false, false is now for this vulture. So we're gonna see. What? Yeah, okay. Well, right collision does get detected. But what's so weird is that means that makes me even more confused, because that's exactly what we tried. We said, where is it? Look, if right collides and we're facing right and they're facing left, which is the scenario when they walk into us like that, we explode the vulture. But instead what's happening is the vulture is what? Just walking through us like we're nothing. We did have that where if we stood still it bounced off us, right? So how did that get broke? By taking out... Oh no, yeah, we did it. But the thing is, we thought something was getting busted. Hold on. Maybe we don't have a vulture exploded in our update. In our update loop for our vulture, we don't have a if exploded. We have a if spawning, and we don't have an if exploded. So it's just the the Boolean variable of our vulture object is for sure getting exploded set to true. But we're not doing anything with that right now. If you look at our ostrich, we only update our ostrich loop if we're not exploded and we're not spawning. So like if we're spawning, do that. Then if not self-exploded. I guess where does it go? Where do we say for our ostrich that if we're exploded, stop, or like draw a new frame or whatever? Draw the new stuffs, right here. So yeah, we would need to say stop drawing if self-exploded, just like we have in our ostrich here. So we're gonna put right here, if not self-exploded, then do this line of code. And at the end of our update function, we're gonna indent everything. And then we're gonna add an end. Right? I guess the end for that. Maybe that's too many ends. Maybe not. I guess let's see it. Yeah, like now it is self-exploded. So now if we have a right collision detection, the vulture should go away. It didn't go away. Because we didn't change our render logic, but it did just stop updating. Okay, so one of my biggest questions is why does... Watch this. Booyah. So, let's say there's an ostrich right there and we're facing it. We're not colliding. Oh, actually, yeah, we are colliding. So that's why, because we're not resetting. Okay, never mind. We'll have to... in our vulture, only render all this if spawning. So we indent this homie. We say if not self.exploded, sure, render. And it won't do that. It'll only render if not self-exploded. So now we should disappear, but the ostrich will still be there. So watch, if we stand still, it collides with us, it'll disappear. But if we turn, I bet we'll die. And the reason that happened is because a collision was detected. Then if we turn, a collision would still be detected. Just because we stop rendering the vulture doesn't mean the vulture's actually gone. Right? So that's why when we turned, we died, because it was still in our collision box because we stopped updating our position, but the last position was in a colliding state. And since we have different states depending on which way you're facing and which collision, that's why it did something different when I just turned. I didn't change my X or my Y. I just changed which direction I was facing and it still killed me. But that makes sense. Where was I? Where was I with this? What were we doing next? We need to delete our vulture for exploded. So if not exploded, update. If not exploded, update. But then here at the end, this. We can put an else. Oh. Why can't we put an else here? Oh. Kind of want to put this. Okay, we didn't need to indent everything. Never mind. Here's what I want to do. Instead of just not rendering us, if we're exploded, I actually just want to say if exploded, which is going to be the end right here. Else if not exploded, do this, but then we need else if exploded, or just an else statement here. So we need to say else right here. No? Oh, it's so hard to see. Okay, yeah, we're off by one. I always mess that up. Okay. This should be if exploded. And if we're exploded, what we're going to do we have 2 vultures right now? Okay, just one. What we will do is we'll say table, table dot remove. And what we're gonna do is from our vultures table, we're gonna remove our vulture 1. That shouldn't change the collision where he disappears, but it should stop us from dying when we turn. Because we'll see, if I use that function correctly, if it's the table, then the value, number expected, got table. So we just need to swap this. Table.insert takes the table first, but table.remove takes the what? Okay. So we should be able to, and the thing is, we don't want to remove it. We don't want to remove it, we actually want to turn it into an egg, so this isn't. Number expected. It needs an index of a table, not just a table. Okay, so hopefully vulture disappears and we are fine. Still hates it. Maybe I was right. I gotta make sure we still got our vulture 1 named vulture 1, because that would be messing it up. We don't have an item. Oh, actually. Yeah. Shoot, yeah, we didn't need to do this. It's okay, it's okay. I'm gonna say I think the problem's coming from this vulture class is trying to use an instantiation of itself. And I'm not sure it can do that. So I'm gonna copy that. Does that run? Yeah. So what I am gonna do is take that logic, put it in our play state, and put it in our play state update function, but only here. Only if vulture1 dot exploded gets true. If vulture1 gets exploded, then we need to table.remove the vultures1. No, we need to remove the vulture1 object. Oh, and you know what? Let me look up table remove real quick, because I think I'm using it wrong. I want the man pages. Here. I literally click on it, right? It looked like the right thing. Table.remove. I don't know. You can, yeah, just show me it. That's the one. Just clicked. Really? What about table.insert? You have that. Dude, really? Where are the manual pages for it? Here, it's table.insert. Where would that be? No, it's actually table.remove. What is this even talking about, man? I don't know how to see what it takes, but let's say it would need an index and a table. So vultures is the table, and the index is the only one in there. Okay, I'm hoping the vulture disappears and we stay fine. Ostrich 91. A nil value. What is it even being called? We don't want that. That was our logic when we were pausing it upon collision, which we don't want anymore. I don't know why it only threw us the bug after. Like, it was working. Okay, here's the moment of truth. If we turn and don't die, we probably removed it from the table. Cool. So now the tricky thing is we need to remove... It's like we need to remove specific vultures from the table. So... you know, Vulture 3 can become Vulture 2 once Vulture 2 dies. Does that make sense? Because now in the table, since Vulture 2 got removed, since he was exploded, there's only 2 index in the table, and that would scoot everything down, wouldn't it? Oh god. I got an idea. I got an idea how we can test this. It's just a lot more work. Yeah. Before. Okay, I think I'm okay with leaving that. I'm okay leaving the mouse position stuff. I'm getting tired. Okay. Well, we're on our way to troubleshooting it. We've got all the logic in there, but it was messing up. I still don't know why it was messing up. Do I? Yeah, right. Okay, so yeah, we can turn this back on now. Now that this is actually executing. We'll see if it bounces off us again. Cool. And if we're walking, it should swap our DX and their DX. Cool. And if I'm jumping, higher lance, you die, bitch. Cool. Oh, it's B to reset a vulture, and don't have it. I've got another idea that I want to see. Perfect. We want the vulture to. Oh, actually, dude, yeah, we might have decent logic, because yeah, that should kill him. But then, what? What? Why did that happen? Bro, why can't I land on a platform? Where did I turn off platform collision stuff? It doesn't make me happy. That I don't know why would our, you know, we were only doing enemy collision. We didn't change anything with our platform collision. We still got the platform collidables. Let's look at our, oh, you know what? We might have been using, wait, just, doing the we've got what? Bottom collides with platform. We've got... But we didn't change any of this. We didn't change any of this. I don't get why we can't walk anymore. Platforms. We can bounce off, you know. We're still colliding with platforms, but we're not able to walk on one. If bottom collision detected, yeah, we're doing all the right logic. Maybe we changed in our bottom collides function. We changed I don't see why we need a buffer. Oh no, yeah, we do on our X. We're setting grounded to true upon a bottom platform detection, right? Platform, bottom detection, grounded to true. We're setting our appropriate height. We're setting grounded to true. So why are we not on our guy standing up? Oh, actually. So we can walk on it, can't land on it. Really. What's going on? I don't know why that's busted all of a sudden. I mean, we haven't tested it in a while, but it wasn't busted a while ago. Shoot. I mean, we just gotta debug it, I guess. We like, is our bottom collision with a platform being detected or not? Okay, here we go. Let's find... So look, our place state, our collidable platforms table gets all of our platform instantiations. Yes. And we give it a name, an X, a Y, width, and a height, which is all our functions take. If you look in our bottom collides, this should be platform, but okay, so it doesn't really take many arguments. Wait, no. This is our collides we want, our actual platforms. It's in our platform class. Here we go. Yeah, name, X, Y, width, and height. Yeah, no position, no Y position on our platform. Okay. So what's happening here? Let me see if, you know, go back here. We'll say if we bottom collides, then, or if bottom collides gets true, right, with platform, we'll have to give it a specific platform if we want to test this. Okay. Yeah, let's give it the middle platform here. This last platform, whatever that one is. Platform 6, platform 5. We'll say, we'll take this code, and then we'll go to our place state, and then we'll say, in our debugging, we're gonna print out we're gonna print out what? Why did you do? gonna say? With platform 5, we're gonna concatenate it with a converted to string of this Boolean value. And the platform is actually platform 5, and the self is actually a player 1. And then we need an X and a Y. Bro, how? Why do you not like that? Oh, no. I don't know why you don't like that. Why are you're not okay with that? You can't just have an if in your render? What the fuck is going on? Oh. No. We've got it. What the fuck? Why are you doing this? Parentheses at line 15. 154. We need a... God damn it. That's fine. So we'll see if when we're bouncing this bottom collide false. It is. So why is it not setting us to grounded? Grounded is not getting set to true. Can we take this out? Because look, we don't even have grounded in here. Then I'm confused. I don't know why it stopped working. Oh. Hold on. It printed. Shit, where did we just print that? Where did we just do that? Yeah, we want... It'll just say if the player's grounded. But that still means we're not getting set to grounded upon that bottom collision. Shit. What is happening here? So look, if we go to our ostrich and we go to our platforms where we're cycling through all the platforms, not the vultures, and then we go to our bottom collides and we say, you know what? Give us minus 50 on our Y. Okay? Now watch us as we raise higher. That means this block of code is getting executed, and that means self-grounded is getting true. But that tells me that somewhere we're overriding our groundedness to false. Somewhere. Checking our self-ground here. So our self-ground is a variable that we assign a platform instantiation, whatever our current platform of colliding with. So I think we're just not assigning our ground. We've got a ground we're assigning to a nil value here because the interpreter yells at us if we don't have that. But upon a bottom collision, I don't know when we would just, was that in there at all times? Because we need to set our self-ground to this platform. And it's a lowercase. And maybe that'll fix us. Shit. See him bounce when he collided on my head though? That was cool. So I wonder when we took that out. We took out our grounded platform bit at some point. But anyway, now that that works, I wanted to print one. I wanted to test one more thing before we quit cease today. And what I want to do is in our play state, look at our vultures table, and it's a vulture 1. I want to print out this vultures table. Shoot, how do we do this? Vultures. We're only going to be referencing. Shoot. You know what? We might need to instantiate, or we might need to put in a new parameter saying this is an index number so that we can reference them. Because I think Lua will dynamically allocate the table size. And that means when one gets removed, everything in the table also gets shifted, and then it changes all the everything for it. So I think we need not only a platform spawn, but an index. Okay. And we're going to assign our index to the passed in parameter. It would be an argument at that point, and then we can do stuff with that, I guess. But we need to say, when we make our vulture right here, it also needs an index, and we'll say vulture 1's at index 1. And then now, the thing I want to print is here. If we do see, I want to do a formatted string here. Or actually, I can just do this. Concatenate with toString. The toString is a vultures okay, we're gonna say it's gonna be vultures index. So it would be vulture1 dot index. Concatenate that with one of these, and then we give it an X and a Y, which is going to be our vulture 1's X, shifted by maybe 10, and our vulture's Y. Vulture 1's Y, maybe minus another 10. So, can you see what this is hopefully doing? Fuck yeah. So we got vulture's 1 there. So the thing is... that's cool, that's cool. Okay, our vulture reset button is busted, which we'll have to fix next episode. Let me say. Fix vulture reset. And I want this to be... If this font's any smaller, since the virtual resolution is only like 200 by 200, it becomes pixely. But why don't we give ourselves a smaller font? We're giving ourselves a thing called smaller font. That'll be half the size of our small font, which means it won't scale properly, but I just want it to be a little smaller. So in our play state, we are going to set the font we're going to set the font only on the vultures debugging. This is all to test if the Lua dynamically allocates the vultures. So my idea is we'll give ourselves a vulture 2, which is actually this vulture. And we also need an index for vulture 2 and vulture 2. And then we need to insert it into the table. I'm not seeing vultures. I'm not seeing the other one. Oh, there's 2. Okay, never mind. The other one is the platform 2 vulture. The higher vulture. Okay. Okay. We need to print debugging for it too. Same with that small font, but it'll be vulture 2's index following the vulture's 2 current position. Smaller font. This is the one we want. And you know what? For now, let's just get rid of our debugging here. Here. Oh, see, yeah, it's hard to read it, but yeah, vultures 2, vultures 1. So my question is, if vultures 1 gets killed by me, what is vulture 2's index? It's really hard to read that font. But it looks like both vultures are stopping to update once it's popped. Okay, well, we don't quite have what we need to really troubleshoot this just yet, because I think we need to just make sure. We need to make sure. Why does it stop both ostriches? It exploded. Or both vultures, rather. If exploded. But it's if self-exploded. So for some reason, the other vulture's getting exploded. Or... no. Hold on. We're at play state. Do we only render... look. We need this. Well, actually, this doesn't fix our problem. See, this needs to be an index, so this should actually be... but we don't know how. I really don't know. I don't know how to check this. I might have to look up how Lua does this. Because I can't even print the debugging for it effectively without knowing what it's actually doing. Okay, so look, we're still Vultures 2, and Vultures 1 was still Vultures 1. So if Vultures 2 really was removed from the table, at the correct index or whatever. Yeah, I guess let's see if we kill one, if Vulture 2's index changes, yeah. Okay, see, there's the problem. If we kill the first vulture gets removed, and then Vulture 2 becomes Vulture 1, and since Vulture 1 is removed from the table, yeah, I wonder if we just say, kind of like what we did. Shoot, where is it, man? We need the vultures. Gosh. Yeah, when we're removing it, we're removing the vulture. God dang it. Let me think. I thought I had it figured out. We just need to, instead of giving the vulture an index of 1, wait. I wonder if I can say, because look, we insert it at Vulture 1 and Vulture 2, but what if we did, we literally, like manually inserted it here. This one gets index 2, that one gets index 1, and then if we kill Vulture 1, well, argument 1 insert. It didn't like that, it just needs the table. Yeah, so it's, I think this, what, like if I give, see, I don't know how tables work well enough in Lua to know how to do this yet, because we're removing the vulture, but if we would remove the higher indexed vulture, vulture 2 then becomes vulture 1, and then it doesn't update vulture 1 because vulture 1 was removed. Yeah, so we have to figure out how to give ourselves a static table. Say, hey, give us a table for 6 objects. We're putting this object at vulture 1, this object at vulture 2, this object at vulture 3. Then if we kill an object, we kill a vulture, vulture 3 is still only using vulture 3's index, and the table isn't actually getting smaller when we remove. So we don't want to actually, see, and that's the thing, we do want to actually remove those values, but we don't want to change the size of our table, and that's what's screwing us over. So either we find a different way to remove those values from the table, and by remove it could mean like overwrite into something, 0 or whatever. But either we figure out a different way to remove it, not using table.remove, or we figure out a way to have a static table, of objects. So that's gonna be my homework. Maybe I'll research that on the stream, but that doesn't really sound like, I'm probably gonna be watching a bunch of videos and stuff, so I don't really want to get copyright striked or anything. But we've got it where, we're rendering debugging info for our vultures. We've got the actual logic freaking, working. Like, well, not if you kill vulture 1. Only if you kill vulture 2 is the logic working. But isn't that something? See, look, vulture 1 just kicked my butt. Okay, so I'm gonna git commit add everything with a message saying what are we've got working logic, working vulture collision logic, but table indexing broken. $233 insertions. I want to see the git diff of that, but okay, whatever, we'll push it. Cool beans. So I wanted to see, actually, Git has a pretty good interface for seeing that. We go to our GitHub, and we go to our Joust. We can load this latest commit. Yo, we're almost at 90, we're almost at 100 commits. Here, if we click this to see the difference, it said we added like 200 lines or some shit. Why are all these say it's added? Added and deleted. What the heck? Do you guys see what's happening? I guess we didn't commit for a while. I guess we really did all of that stuff. Oh, see the tabs. That's why it pulled up so many changes, because the tabs here. Yeah, that's why it pulled up so many lines difference. We have to go back and fix those tabs because we actually didn't need to indent there. But so yeah, look, we added the index parameter to our vulture object, vulture class. Changed a bunch of shit. Yeah, and we should have taken out the smaller font. It wasn't clear, so we should have taken that out before the commit, but it's whatever. Anyways, tomorrow I'm gonna research how tables get used and if we can assign a static table of a certain size. And if we can't, I have to figure something else out, but surely there's a way, because this is, you know, you need to do this type of shit in video games all the time, so there's a way. I know there's a way to do it. It's probably easy, so not too worried about it. Thanks for watching.